Hi, this is Victor and welcome back to my math tutoring channel. In this video, we'll do some basic exercises about integration. This video is meant to, my audience are the beginners in integration. So this is an introduction. I will do other videos with more difficult exercises, but this one is for beginners. Before watching this one, there is video number 10 that I explained the formulas, the basic formula of integration, and this will help a lot if you take a look. It's not a long video. It takes like even less than 1 minute. Just open it, take a screenshot of the formulas or copy them. I will be using those formula. So let's start. Let's start with example number 1, integral between 2 and 6 of 1 dx. And in my video number 10, we said the integral of k dx is equal kx, because I will explain to you now, if I have the derivative of x is equal 1. So the antiderivative of 1 is x. So that's why here it becomes x between 2 and 6. And when I have boundaries to my integral, I don't have to put plus c, but the first time I have to replace x by the upper boundaries, which is 6 here, so my x becomes 6, minus the lower boundary. I replace x with the lower boundary, minus 2, and my answer is equal to 4. And as you see, I don't put plus c because my integral has boundaries. Let's do example number 2. Integral of x5 dx. Here I don't have boundaries. And I think my second or my third formula, actually it was my third formula, when I have integral of x to the power of n, it becomes x to the power n plus 1 divided by n plus 1. And here my 5 here is my n, so it becomes x to the power 5 plus 1 divided by 5 plus 1 plus c. It's equal x to the power of 6 divided by 6 and plus c. If you want to integrate x to the power of 6 divided by 6, you will see it become x5. Why plus c? Because x6 divided by 6, let's say plus 2, the derivative of that is equal 6x5 divided by 6, and the 2 becomes 0, and 6 divided by 6 is x5. So if I have plus 2 or minus 2 here, or like plus 3 or minus 3, it is always 6x. It is always x5. So to account to this here, the plus and minus a constant, I have to put the plus c. That's the reasoning of the c. Let's do another exercise. Integral of 5 divided by cubic root of x to the power of 4. This, the 5 is a constant. I can take it outside my integral and it become 1 divided by x to the power 4 divided by 3. Because like it is cubic integral, I have to put it in the denominator of my exposure, dx. And here there is a dx. So this is equal to 5 integral of x to the power minus 4 over 3, because we jumped from the denominator to the numerator, and then I apply my rule. It becomes 5 x to the power minus 4 over 3 plus 1 divided by minus 4 over 3 plus 1 plus c. It's 5 times, this is minus x to the power minus 1 over 3 divided by minus 1 over 3. It is equal, and here because of the division it become multiplication, but I have to flip minus 1 over 3. It become minus 5 times 3, and the x to the power minus 1 over 3 will go to the denominator and become x to the power 1 over 3 plus c, and 5 times c is 15 divided by cubic root of x plus c. Let's do another example. integral of cosine x divided by sine square of x. Why did I make it that long, that line? Dx. This I can write it as cosine x divided by sine x times sine x dx. And I know cosine divided by sine is cotangent. It's equal cotangent x, and 1 over sine x is equal cosec x dx. And there is a formula that said the integral of cotangent x cosec x is equal to sec x plus c. And the formula is in my video number 10. Now let's do another example. X to the power of 3 plus 5 divided by 3x dx. And as I said, if I have plus here or minus, I can split my integral into two. It becomes integral of x to the power of 3 divided by 3x plus integral of 5 divided by 3x. And here there is a dx. Dx means I'm integrating in relation of x. I want the antiderivative of x, 5 divided by 3x, but x is my variable. So the first integral, I can take out 1 over 3 outside because it is a constant, and it becomes x to the power of 3 divided by x is x to the power of 2 dx. And the second integral, I can take 5 divided by 3. It's my constant, and I will end up 1 over x dx. So 1 over 3, and the third formula in my previous video number 10, would show me that integral of x2 is equal integral of x3 divided by 3 plus c1 plus 5 over 3. And I know the derivative of ln of x equal 1 of x, so the antiderivative of 1 divided by x is ln of absolute value of x plus c2. Why absolute value? Because ln of a negative number does not exist, and I know the derivative of ln of x is equal 1 divided by x, so the antiderivative of 1 divided by x is ln of x. So this I can write it 1 divided by 9 x to the power of 3 plus 5 divided by 3 ln of x plus c, where c equal to c1 plus c2. Let's do another example. I will do it in another page. It's a bit long, this one. Integral of 4x to the power of 3 plus 2x to the power of 2 plus 4x divided by x squared plus 1 dx. Because I have a plus in the denominator, I cannot split my integral, so I will do the Euclidean division. So I will do 4x to the power of 3 plus 2x to the power of 2 plus 4x divided by x squared plus 1. So I have to multiply something by x squared to have 4x to the power of 3, that is here. So my answer is 4x. 4x times x squared is 4x to the power of 3, and 4x times 1 is 4x, and I have to minus those. It becomes 0. 4x3 minus 4x3 is 0, plus 2x to the power of 2, and 4x minus 4x here, it is 0. And now I have to multiply something by x squared to have 2x squared, and my answer is 2. 2 times x squared is 2x squared. 2 times 1 is 2. And I have to minus those two. 2x squared minus 2x squared is 0, and minus 2. So my integral, I can write it in like that integral here. I can write it like x squared 4x plus 2. 4x plus 2 minus 2 divided by 4x plus 2 dx. And because of that minus here, I can split it into two integral. It becomes integral of 4x plus 2, actually into 3 integral, because I have a plus here, 4x dx plus 2 dx minus 2 over 4x plus 2 dx. So 4 is a constant, I take it outside my integral, and the integral of x is x squared divided by 2. 2 is a constant, I can take it outside my integral, and the integral of dx is x. And then here I will do it in 2 steps. I keep the 2 here, and then I can factor out 2 in the denominator. It becomes 2x plus 1 dx. So my 4 divided by 2, it becomes 2x squared, because I can simplify by 2 here. It becomes 2 here plus 2x. And here I can simplify by the 2 minus 1 over 2x plus 1. dx. And now I will introduce you to the changing variable. The changing variable is, I don't have any formula that resembles to this one, and it is difficult to do it in any other way. So I can say let u equal 2x plus 1. So my du, derivative of u, is equal to dx. And if I want dx alone, because I have dx here, I can divide by 2 here, and I can divide by 2 here. So my dx becomes du over u. So my integral will become 2x squared plus 2x minus integral of 1 over u times du over 2, because 2x plus 1 I replace it by u, and the dx I replace it by du over 2. So 1 over 2 is a constant. I can take it outside my integral. So it becomes 2x squared plus 2x minus 1 over 2 integral of 1 divided by u du. And the antiderivative of 1 over u is ln of u, because the derivative of ln of u is 1 over u. So this will be equal to x squared plus 2x minus 1 over 2 ln of u plus c. And now I have to put u to its value. My u is equal to x plus 1. So it is 2x squared plus 2x minus 1 over 2 ln of 2x plus 1 plus c. Okay, that's the end of my video. In my second video, we will do the changing variable in an integral, and then after the video after, we will do some more trigonometric and more difficult integration. Thank you for watching, and if you like my video, please subscribe, and it's nice if you can put some likes. Thank you.